Sir, this is Shoaib, Mechanical Engineering. My roll number is 234G1A0329. Subject Fluid Mechanics and Hydraulic Machines. Course code 23MAC402. Today my topic is forces of jets on stationary. Forces of jets on stationary. Introduction to jet forces. The study of force exerted by jets in crucial in various engineering applications. Jet refers to fluid streams which can be gases or liquids directed towards a stationary object. Understanding signing systems like propulsion engines and hydraulic systems. Basic principle of fluid dynamics. Fluid dynamics governs the behavior of fluids in motion and interaction with surfaces. Bernoulli's principle explains how pressure differs in moving stationary fluids. The forces exerted by jets can be analyzed using the principles of momentum and energy conservation. Fluid mechanics. Types of jets. Jets can be classified into free jets, submerged jets, and wall jets based on this behavior. Free jets are those that discharge into the atmosphere without any obstruction. Submerged jets interact with surrounding fluid while wall jets flow along surfaces affecting their dynamics. Forces acting on stationary objects. The force exerted by a jet on a stationary object can be calculated using the momentum change principle. The reaction force is equal to the change in momentum of fluid as it strikes the object. This interaction results in a net force that can be cause motion or deformation the object. Applications in engineering. Jet forces are applied in various fields including aerospace and automotive engineering. In propulsion systems, jets provide thrust and expelling mass at high velocity. Hydraulic systems utilize jets to create forces for various lifting and moving applications. As shown in this figure, the jet is experimental methods to measure forces. Experimental can be conducted using force sensors to measure the impact of jets directly. High-speed cameras help visualize the interaction between the jet and the stationary object. Computational fluid dynamics (CFD) simulations are also used to predict jet behavior. Simultaneous are also used to predict jet behavior and forces. Factors influencing jet forces. Several factors influence the force exerted by jets, including velocity, density, and angle of incidence. The shape of the nozzle and the distance from the object also play significant role. Understanding these factors is essential for optimizing designs in practical applications. As shown in this figure, pipe nozzle, plate, jet of water. Case study: jet engine testing. Jet engines are tested using stationary models to measure thrust and efficiency. The forces generated by the jet are crucial for assessing engine performance under different conditions. Data collected from these tests informs improvements in engine design and fuel efficiency. A jet engine is tested in the stationary test stand to measure its static thrust over a spherical surface. With R is equals to 3 meter centered intake opening, the velocity has uniform magnitude. Vi is equals to directly radial inward. See figure and insert at the density of the incoming air. Pi is equals to 1.2 kg by meter at the exit. The velocity is uniform and directed along the negative y-axis with a magnitude of Vc is equal to 450 meter. The exhaust is that evaluated temperature with a uniform density. Pe is equal to 0.6 kg per meter cube and exist over area AC is equal to 1.4. Calculate the velocity magnitude V1 at the inlet. To control volume shunt, calculate the momentum flux the y direction through the control volume shunt. Following the streamline upstream from the let one will eventually reach a point where the velocity is zero and the pressure is at atmospheric levels. Use this information to calculate the pressure to control volume inlet. Calculate the net thrust generated by an engine clearly as shown in this figure. Challenges and considerations. Currently, measuring jet forces can be challenging due to turbulent flow and environmental factors. Safety precautions are necessary when dealing with high-speed jets and pressures system. Continuous research is aimed improving measurement techniques and understanding complex conclusion and future direction. The study of jet force, a stationary object that remains visual area of research. In fluid mechanics, future advancements may lead to more efficient design in propulsion and hydraulic system. Ongoing research will continue to enhance our understanding of fluid sector interactions. Thank you for watching.